Okay, so this is a question asked on polymorphism. What is polymorphism? Polymorphism means one entity or one thing, multiple forms. For example, you see me here standing in front of you as an instructor, trying to guide you, trying to help you with computer science. Me, the same person, is a son to my mother. I am also a brother to my sister. So I am one person playing multiple roles depending on multiple scenarios. So as and when the time changes, my role also changes. Similarly, in polymorphism, what happens is we have one programming entity taking multiple forms or multiple functionalities depending on the type of situation. Remember, polymorphism is implemented in two ways, or polymorphism is implemented at two times. This classification will help us to get the answer to this question which has been asked to us. So polymorphism can be implemented at two times. One is compile time. So we have compile time polymorphism, and the other is runtime. So what is compile time polymorphism? In compile time polymorphism, the resolve or the resolution of the entity to the scenario is done at compile time. Compile time polymorphism means to resolve the entity which has taken multiple forms at compile time. And what is runtime polymorphism? Runtime polymorphism refers to resolving the multifaceted entity at runtime. Instead of leaving it at compile time, we defer it to runtime in runtime polymorphism. Now, compile time polymorphism in C++ is implemented using function overloading or operator overloading. So we have function overloading and operator overloading. Using either of these two strategies or either of these two programming methods, we can implement compile time polymorphism. And what about runtime polymorphism? Runtime polymorphism is implemented using function overriding. In function overriding, what happens is we have a base class. Let's say we have a base class A, and from that we have derived class B to have properties of class A. So we have a base class A. From class A, class B has derived some properties. Now let's say class A, among other things, has an implementation of a method by the name of F1. Right? Similarly, class B has inherited some of these properties of class A. So it has inherited F1, and what it does is it defines F1 with the same arguments and parameters as it is defined in class A. So then the function F1 in B will override or is set to override the function F1 in A. So the derived class function overrides the base class function. This is what you call function overriding at a very basic level. We do not need to know much in order to answer this question, but this is the gist of it. And what is function overloading? Function overloading means to have one function name taken different types of arguments or different numbers of arguments and change its functionality accordingly. For example, let's say I'll just talk about function overloading with an example. Then I think things will be a lot clearer. So you can pause the video for a moment and note down this classification. So function overloading is a very useful programming tool available in object-oriented programming languages. So what happens is, let's say I have a function by the name of, let's say, area, right? And this function takes in one integer argument, and then I have another function area which takes in, let's say, two integer arguments, and I have another function area which takes in one double valued argument. Now, as you can see, we have three functions, all have the same name, but look at the function signature. The function signature refers to whatever is enclosed within parentheses. This refers to the function signature, and this entire thing is the function prototype. So the function signature is differing. Now, how is it differing? See, this function area has or will expect one integer argument. This function area will expect one double type argument. So these two functions are differing not in the number of arguments, because the number of arguments that this function is expecting is 1. The number of arguments that this function is expecting is also 1. So they're not differing in number of arguments, but they're differing in types of arguments. So these two functions are said to be overloaded. What about the middle one? See, the middle one is differing with both function 1 and function 3 in types of arguments, right? In fact, it is differing in types of arguments with this function, because this is taking a double and this is taking int, but it is also differing in number of arguments, right? This function is expecting 2 arguments, this function is expecting 1, and with this function it is differing in both, not in both rather, because this takes in 2 arguments and this takes in 1, so it is differing in number of arguments, but it is the same when it comes to the type of arguments. This is expecting 2 integer type arguments, this is expecting 1 integer type arguments. So these two functions are also overloaded, so are these two, and so are these two. So these three functions are said to be overloaded. And let's say I have something like this. What about the return type? Does the return type play any role in function overloading? Mind you, the return type of a function plays absolutely no role in function overloading. The return type of a function will have nothing to say regarding two functions being overloaded or not overloaded, right? So remember, the return type has no role to play. Now, so this was function overloading, and what about operator overloading? Operator overloading, to just keep it simple, is something like this. Let's say I have int a, b, and c, and I write c equal to a plus b, right? Let's say I have a few statements in between, and I write c equal to a plus b. Now, the plus operator in this case is adding two integer numbers and assigning it to another integer value or another integer variable. Let's say if I had something like this, string str1, str2, and str3, and I write str3 equal to str1 plus str2 and some programming statements in between. Now what will happen? What role will the plus operator play in this case? In this case, the plus operator will concatenate these two strings and assign it to the string str3. So depending on the context, see, the context in this case is strings or string types rather. So the context in this case is the string types. The context in this case is integer types. So depending on the context, the plus operator is playing different roles. Depending on this context, the plus operator is playing the role of addition. Depending on this context, the plus operator is playing the role of string concatenator. So this is operator overloading. One operator or the same operator playing different roles in different scenarios. Right? So this is how you would implement operator overloading in any object-oriented programming language. You can also do this in C++, but with some amount of syntax modifications. Anyway, we'll not be concerned with that here. Now let's come to the question. Polymorphism in C++ can be implemented at compile time or runtime. This is statement A, and this is definitely correct. We have seen it just now, right? We have seen the classification. So polymorphism in C++ can be implemented at both compile time as well as at runtime. Now what about the second one? Compile time polymorphism is implemented using function overriding. No. As we just saw, compile time polymorphism is implemented using either operator overloading, or function overloading. Function overriding is a case of implementation of runtime polymorphism. So this statement is incorrect. So which of the above statements is correct? Statement A only. So I hope you learned something useful from this video. Thank you.